I'm Nick Jester, and I will be explaining what is the inverse of a matrix and how do we find it. So first of all, if we think of matrices as linear transformations, we know that the columns of this matrix A tell us where I hat and j hat respectively land. So after this transformation A, the non-standard basis vectors are now in some spot. Basically, applying the inverse to this matrix A undoes this transformation and puts it in the same spot as started, which is the same as multiplying a vector by the identity matrix because it does nothing. So a matrix is invertible if it is square and if it is a bijection. So that means its columns are linearly independent. So how do we find these inverse matrices? Well, for a 2x2 matrix, it's pretty simple, but it's different for higher dimensions. So with a 2x2 matrix, all you have to do is do 1 divided by the determinant. And if the determinant is non-zero, your matrix is invertible. So you just do this and you multiply this by these values, however altered a little bit. So you negate B and C and you swap A and D. So now you have A here and D here. So this would give you A inverse for a 2x2 matrix. But if your matrix is higher dimensions, it's not as simple. What you have to do is you have to row reduce. So what you would do is you would row reduce A with the identity matrix of its dimension, and you want to turn A into the identity matrix. So after you do this, you would get IN with A inverse on the right side. So that's how you figure out the inverse of a matrix and whether it's invertible and understand what is an invertible matrix. Thank you.